Hello everyone! So for today we are going to explore chapter 8, limit and continuity. So today we're going to explore 8.1 limit. So limit is divided into two parts, which are part A and part B. Part A is limit at a point and part B is limit at infinity. So now we're going to explore part A first and then part B. So for part A, is divided into four cases, which are case 1, value, case 2, 0 over 0, case 3, infinite limit, and also case 4, piecewise function. So we're going to explore it one by one. Let's explore it together. So the first case is value. It is when you substitute x to fx until you get the value, and the value will be your answer. So there are a few examples here. So the first example is limit x approaching to x plus 3. So you can substitute 2 into x. So 2 plus 3 is equals to 5. So whenever you substitute x into fx, limit will disappear. So your answer will be 5. The second example is limit x approaching 3 to x plus 1 over x squared minus 3x plus 1. So you substitute 3 into x equals to 2 times 3 plus 1 over 3 squared minus 3 times 3 plus 1. So you will get 7 as your answer. So that is value, the first case. Okay, so for the next case, case 2, 0 over 0, I divide it into 3 subcases, which are factorize, multiply, conjugate, and also absolute value. So we're going to go through them one by one together. So the first one. In this type of question, so limit x approaching 2, x squared minus 3x plus 2 over x minus 2. So when you substitute 2 into x, you will get 0 over 0. So as you can see in this equation, you can see there is a quadratic equation. So in this, if you see a quadratic equation, you can factorize it. So you can get x minus 2 and x minus 1. So limit x approaching 2, x minus 2 times x minus 1 over x minus 2. So you can cancel out x minus 2. So you will get a new equation. Limit x approaching 2, x minus 1. So now you can substitute 2 into x. So 2 minus 1 equals to 1. That will be your answer. Let's see, the next subcase is multiply conjugate. In this case, you will see third. So when you substitute 6 into the equation, you will get 0 over 0. So when you see third, you will multiply conjugate. So limit x approaching 6, 2 minus third x minus 2 over x minus 6 times with the conjugate 2 plus third x minus 2 over 2 plus third x minus 2. So you will multiply it. So the answer would be limit x approaching 6, 4 plus 2 third minus 2 minus 2 third x minus 2 minus x minus 2. And then over x minus 6 times 2 plus third x minus 2. So we'll be able to cancel out these two. So the answer would be limit x approaching 6, 6 minus x over x minus 6 times 2 plus third x minus 2. So in this case, you can change 6 minus x into x minus 6 and then put minus in front. So you can cancel out x minus 6. So your answer would be limit x approaching 6, negative 1 over 2 plus surd x minus 2. So you can substitute 6 into x. So negative 1 over 2 plus surd 6 minus 2. And then your final answer would be negative 1 over 4. So the last subcase is absolute value. So in this case, if you see a caged equation, that is absolute value. So you need to solve absolute value first. In order to solve absolute value, you need to part it into two equations, positive and negative. So the positive one would be approaching from the right, and the negative one would be approaching from the left. So absolute value x minus 5 would be x minus 5, x more than equal to 5, and also minus negative x negative 5, x less than 5. So in this case, the question asks us to find limit x approaching 5 from the left. So that means we need to choose the one that is negative, which are our x approaching 5 from the left. So substitute it into your equation. Limit x approaching 5 from the left, x minus 5, negative over negative x minus 5. So you can cancel out x minus 5. Then the answer would be limit x approaching 5 from the left, negative 1. So the answer would be negative 1. That will be your answer. So our third case is infinite limit k over 0. So let's look at our question. Limit x approaching 0, 1 over x squared. So when you substitute 0 into x, you will get 1 over 0, which is constant over 0. So what you need to do is to solve limit x approaching 0 from the right and limit x approaching 0 from the left. Let's solve it. So limit x approaching 0 from the right, 1 over x squared equal to 1 over 0 from the right squared. So it is equal to positive infinity. And limit x approaching 0 from the left, 1 over x squared equals to 1 over 0 from the left squared. So you will get positive infinity. So since limit x approaching 0 from the right, fx is equal to limit x approaching 0 from the left, fx is equal to positive infinity. So your limit x approaching 0 fx exists but undefined. So if your answer is different, for example, you get positive infinity and negative infinity, so limit x approaching 0, fx does not exist and also undefined. So that is case 3, infinite limit. So this is case 4, piecewise function that is involving number line. So this is the last case of part A. So usually you will be given this type of question. So when you get this type of question, you can turn it into a number line to make sure you can analyze the question better. So let's see the question. So the first question is evaluate limit x approaching 1 fx. So when they ask you to evaluate, you have to determine whether limit x approaching 1 fx exists or does not exist. So let's see. When x equal to 1, you have to see it from x approaching 1 from the right and x approaching 1 from the left. So x approaching 1 from the right is 4 minus x squared, and x approaching 1 from the left is x squared. So the answer would be like this. Limit x approaching 1 from the right, 4 minus x squared. So you have to substitute 1 into x. So 4 minus 1 squared equals to 3. And then limit x approaching 1 from the left, x squared. So you have to substitute 1 into x squared equals to 1 squared. So it is equals to 1. So since limit x approaching 1 from the right, fx, does not equals to limit x approaching 1 from the left, fx, so limit x approaching 1 fx does not exist. So question B, evaluate limit x approaching -1 fx. So let's see from the number line. X approaching -1 from the right is x squared, and x approaching -1 from the left is x plus 2. So the answer would be like this. Limit x approaching -1 from the right, x squared, equals to -1 squared. So the answer would be 1. And then limit x approaching -1 from the left, x plus 2 equals to -1 plus 2 equals to 1. So since limit x approaching -1 from the right, fx equals to limit x approaching -1 from the left, fx, are both equal to 1. So limit x approaching -1, fx exists. So that is piecewise function.